Hi again. This is a forces recap from the notes from last time. So what I mentioned in class was that a force is all it is just a push or pull on an object. So what I also mentioned was that there are more than one forces acting on an object at any time. So here's the situation. We brought in this concept called net force. Okay, and all net force equals is the sum of all forces. Okay, sum of all forces. So let's take a peek at a situation. Let's pretend we have a book sitting on a table. Okay, and it's just sitting there. Okay, there's nothing happening. It's just it's not accelerating. It's just sitting there. So we would consider this to be a non-accelerating object. And the two forces acting on this book, first one would be the weight of the book. Now, if that's the only force that existed, the object would accelerate down, which we know is not the case because we generally don't see books hurling through the center of the earth. So we need some balancing force here. Okay, the balancing force is an equivalent force that is pushing up on the book. Okay, and we call that the normal force. Okay, without the normal force, that book would be coming down through the center of the earth, and we know that doesn't happen. Now that's on an object that's just still. It's not accelerating. Pretty easy to find out. So if I wanted to say that the weight of the book was equal to, let's say, 20 newtons, then the normal force would have to equal, Fn would have to equal 20 newtons as well, but in the opposite direction. Okay, so I would call the normal force positive and then the weight negative. Okay, so that's pretty much it on the adding up the forces on an object that's not accelerating. Now let's look at another situation. Now the net force here, okay, is sum of forces. So if I look at what's here, I've got the normal force plus the weight. Okay, so the net force on this object is the normal force, which is 20 newtons, plus the weight, which is negative 20 newtons. And what I have left, okay, shouldn't be that hard to understand the fact that there is really no net forces on the book. The net force is 0 newtons. Okay, so we can say this book is not accelerating. Okay, so that's pretty much it on a non-accelerating object. Now, if I were to take and apply this to the good old Tug-of-War, where I have a group of people, or we'll actually call this one person on one side, okay, pulling on a rope against this other person or group of people, okay, and they're pulling this way. If I were to put some numbers on this, if this person were pulling with 100 newtons to the right, we call that positive 100. If this person were pulling with negative 101 newtons to the left, obviously the winner is going to be this guy right here. Okay, this guy or this girl is going to win. And how much do they win by? Well, let's check it out. Net force equals the sum of all forces. So on this system, we're looking at the right and the left. So we have negative 101 newtons plus 100 newtons. Okay, so the net force is equal to negative 1 newtons. Okay, which is going to the left. So that's what's left here. Okay, that's the net force in a tug-of-war. Okay. Now, this has implications for accelerating objects as well. So if we look at Newton's second law, the sum of forces is equal to the mass multiplied by the acceleration. Okay, let's take a peek at that. Let's look at one where the net force does not have to be calculated. So this is a situation where we have an object. Forgive the box there. We'll have the object on a table. Now, in real life, we've got friction on this. We've got applied forces. We've got normal forces. We've got weight. But in this situation, let's just put a number on this. I'm going to call this 12 kilograms. Okay, that box is 12 kilograms. If I know that the mass is 12 kilograms, and I know that the acceleration of the box, we'll say it's accelerating this way, is, let's say, positive 2 meters per second squared. Okay, I know that there has to be a force applied to the box to get it to do that. So, knowing that there needs to be a force to provide an acceleration to the mass, I can figure out what force that would require to move that or accelerate that box at 2 meters per second squared. So very simply, okay, is the mass of 12 kilograms multiplied by the acceleration. Okay, and then the force, the net force needed to do that would be 12 times 2, or 24 newtons. Okay, so the answer here is 24 newtons. Now this is a simplified version because I didn't put friction here. Okay, I didn't add other forces here, but this is the simplified version where we have an object that is acting without all those other forces. Okay, so let's recap here. Force is mass times acceleration. If I'm given a mass of 12 kilograms and an acceleration of 2 meters per second squared, all I need to do is just a little substitution. Force equals mass times acceleration. And the force needed, we'll actually put a positive sign here, is positive 24 newtons. And remember, the Newton, just a little aside, the Newton is approximately the weight of a medium-sized apple, because as Newton was sitting next to the apple tree, an apple hit him in the head. So make the connection here. All right, that'll be it for this video. Thank you, and have a wonderful day.